started. Hopefully a lot of this is review. I know you did some cerebral blood supply, maybe spinal as well in anatomy. That's kind of new. In the past, I don't think they were doing that. So you guys are at a little bit of an advantage for this class, having had some of that information already. Just a few quick announcements before we start. Just so you know, remember you get to drop 2 quiz grades in this class. Maybe you're glad about that after this last one. So if you look on Blackboard, if you've been checking Blackboard, there's 5 quiz grades that are already posted. So when I grade these, if your score is higher than any of the ones that you've taken in the past, I will just go in and substitute. All right, so you may see a lower grade go away and be replaced, and that's what I'll do for the next quiz as well. So feel free to double check me and make sure that I haven't made a mistake. Hopefully you've kept all of your old quizzes, but that's sort of how that process will work. And then for next week, the readings are out of a different book, kind of that supplemental book that I said that, feel free to buy, but it's expensive. So those are posted on Blackboard. They've actually been up since the beginning of the semester, but I don't think anybody's been working weeks and weeks ahead of time. So those are there. Just take a look. I forget what the chapter numbers are. I think they're 15 and 18. I think it's chapter 18, and that is for next week. It's on limbic system, emotion, regulation, things like that. So just so you know that it's there. Everybody turn in their papers. Any questions or issues before we get started? All right, well, let's do it. So again, we are going to be doing blood supply today, and this is cerebral blood supply, which will be our focus, but we will talk about cerebellar blood supply, spinal blood supply, brainstem blood supply as well. So it's not going to be just isolated to the brain, but it is important to look at blood supply to the brain because a lot of bad things can happen when blood supply to the brain goes away, and that's what we'll talk about mainly in the afternoon. But keep in mind that even though the brain is only about 2% of the body's total weight, it gets about 20% of the blood supply. So it is an organ that needs a lot of nourishment, that works very hard and needs a constant supply of oxygen and glucose to maintain that function. And the circulatory system is also responsible not only for providing nutrients, but taking away toxic or non-necessary substances from the brain as well. So when you have a lack of circulation to parts of the brain, it's not only that those parts of the brain are losing their supply of oxygen or glucose or whatever, they're also losing the ability to get rid of bad things. So it's sort of that dual impact that can lead to cell death and eventual functional loss. All right, so we're going to start today with some videos, and I think this is helpful to orient you to the big picture, and then I'll break it down sort of artery by artery and where the supply is for each one. But it was helpful for me to, as a reminder, get a bigger picture to begin with. This one. Don't worry about this because I'm going to skip ahead. Because you guys don't need an overview.
How's my skull? And it's made up of these billions and billions of neurons. Their function's done. But having said that, the functions that I sort of listed earlier for each lobe, that's what that lobe sort of specializes in. So that's some really basic brain anatomy. So by now it's really clear that the brain is a really metabolic organ. So it's going to need a lot of fuel, it's going to need a lot of glucose and a lot of oxygen. And it gets that by having a really rich blood supply. So here's sort of a glimpse at the major arteries of the cerebral vascular system. And it looks really complicated, right? I mean, wow, there's so many blood vessels there. It's kind of a lot to take in. And it is a bit of a handful, so I find that it's easiest to look at them from the underside to learn about the different blood vessels that supply the brain. So let's look at that now. And I appreciate that it doesn't seem any easier from the underside, but we can go through it together. So let me just reiterate that the image on the right over here, we're looking at an underside view, right? So we're looking up from underneath at the brain and looking at the all sort of start to come together and make sense too. So you just have to sort of bear with me now. So let me start by saying that although it looks really, really complicated up top, up here, all of the blood that gets to the brain is essentially coming from four major arteries initially, okay? So you've got one here. So this is the right internal carotid artery. This is on the right side. And then you've got an internal carotid, I'll just abbreviate it ICA, on the left side. So that's two out of our four major arteries. And then you have this one here, which is the right vertebral artery. And then you have the left one over here. And by the way, they're called the left and right vertebral arteries because they sort of run up on either side of your spinal column. So within your vertebrae bones. And the internal carotids, they run on sort of the anterior, on the front part of your neck. Alright, so these are the four main arteries. So two vertebral arteries and the two internal carotid arteries, right? Left and right of each. And actually, notice that the two vertebral arteries, they sort of come together, right? They come together and they form this one artery here that almost looks like a little centipede. And that artery is called the basilar artery. Basilar artery. So we'll actually include that as one of our major vessels as well, basilar. So let's find those same arteries over on the other view, the interior view here. So here's your right vertebral artery. Here's your left vertebral artery. Here's your basilar artery. So that's already 3 out of our 5 major arteries. And then your internal carotids, they're actually a bit funny to find on this one. They actually end right about here. You can see that I sort of snipped the arteries here. And in fact, this is right about where the internal carotid arteries end. And we'll find out what they sort of turn into in a few minutes here. So those are the ends of the two internal carotids. Alright, now we can sort of get stuck into figuring out what all the rest of the arteries are. And, you know, it is a really complicated sort of area, so I've always found that the easiest way to do it is to think about which arteries serve the cerebrum, which arteries serve the cerebellum, and which arteries serve the brainstem. So let's take a look here. Let's first look at the cerebrum. So coming off what used to be the ICA, the internal carotid, we have the creation of our new vessel called the middle cerebral artery, the MCA. So I'll draw that in here in solid. I'll color it in solid, but then notice how it sort of dives underneath this lobe here. So we'll just do that in almost a cross hatch pattern. Okay, so this is the middle cerebral artery, and this is going to serve, and remember there's one other side of the solid here, and when it sort of dives a bit deeper into the brain lobes, we'll show that it's not superficial anymore. And on the anterior view, it's a little bit tougher to see, of course, but we do our best to draw it in. So there it is there. And it sort of heads out laterally, okay? And it says the outside part of the brain here. Now, what else serves the cerebrum? Let's actually do them all in blue here. We'll just use a different shade of blue. All the cerebral ones we'll do in blue. So the next thing that we have are the anterior cerebral arteries. And the anterior cerebral arteries supply blood to the inner parts of the frontal lobes. Right, so you can really see how the anterior cerebral artery supplies blood to the inside part of the frontal lobe. Now, we have a middle cerebral and an anterior cerebral. The only thing we're missing is a posterior cerebral. And we're actually not missing it because we're about to find it. So our posterior cerebral artery is right here. And you can see that it sort of dives deep, sort of above the cerebellum here. So let's put that in the dotted in sort of hatched lines here. And it's really tough to see on the anterior front, but it's about right there. So we're almost done all the blood vessels of this cerebrum. The one thing I want to point out is that notice how the anterior cerebral vessels are connected by this little bridge here. And this bridge is called the anterior communicating artery. And notice how the middle cerebral artery and the posterior cerebral artery are joined by this bridging artery here. Right? And there's one on each side here. And this is called the posterior communicating artery. So one thing that might become really apparent to you is now these arteries that serve the cerebrum have taken on almost a circle of Willis if you want to use the eponymous name. And why is that really important? Well, just think about this. Let's say you get a little blockage in internal carotid here on this side. Well, you can imagine that now we're sort of restricting blood from getting up this internal carotid. Remember we said it was a major artery, the internal carotid. Blood can't enter the circle of Willis and can't enter the middle cerebral artery from this internal carotid anymore. But because we have this collateral circulation provided by the circle of Willis, where blood can sort of go around the circle, blood can still come up from this internal carotid and get around the circle and go into the middle cerebral artery from here, right, from the other side. And blood can still continue to come up these vertebral arteries and up the basilar artery and still perfuse or fill up the entire circle, and thus it really minimizes the chances of you having some type of brain injury due to lack of blood flow to a part of your brain, because there's this collateral circulation, the circle of Willis. Really important. Good, so those are the three major arteries of the cerebrum, the middle, the end.
Alright, we're going to do one more. Talk about cerebellum. Again, I will
So we know that
pull
the
it all together.
cerebrum is primarily supplied by the anterior cerebral artery, the middle cerebral artery, and the posterior cerebral artery. So let's actually draw out on the surface of these brains here, let's draw out their supply areas, their vascular territories. So let me orient you here. So here's that side view of the brain again, looking directly from the side. And this brain here, this is just one half of the brain. So what we've done is essentially we've cut away one half of the brain, right? And we're looking at the remaining half, right, from this side. So remember we said your anterior cerebral artery is going to be right between these lobes. Remember we said the anterior cerebral artery is here. So it's going to serve the inside parts of the lobes, right? So your anterior cerebral artery, it's going to serve blood to the inside part of the medial part of your frontal lobe, as well as just a little bit on the outside as well. Sort of like a little bit of spillover from the blood supplying the medial part of the frontal lobe. Now your middle cerebral artery is responsible for doing a lot of the lateral part of the brain, the outside part of your brain. So it's going to do most of the lateral part of your frontal lobe. It's going to serve blood to it. It's going to supply a lot of the lateral aspect of the parietal lobe. It's going to supply a little bit of the occipital lobe, and it's going to supply a lot of the temporal lobe, all laterally. Okay? You're not really going to see too much middle cerebral artery supply on the inside part, the medial part of the brain, except you might see a little bit sort of a spillover at the edge of the temporal lobe. You might see a little bit right around there. And now the posterior cerebral artery. The posterior cerebral artery is going to do the rest of the lateral aspect of the cerebrum. So that's some of the parietal lobe, most of the occipital lobe, and a fair chunk of the temporal lobe. So that's the occipital lobe on the outside and the inside, and that bit of the temporal lobe on the outside and the inside. Alright, so that's the major blood supply to the cerebrum. Let's now look at the blood supply to the cerebellum. Alright, so let's make the theme, our color scheme of the cerebellar artery. Let's make it this nice little purple here. Purple and pink. So the main arteries of the cerebellum are the superior cerebellar. So I'll draw in purple here, superior cerebellar. So they're actually coming off the basilar artery and wrapping backwards to reach the cerebellum. And it's really tough to see on this anterior view. You'll just have to trust me there. The next one is the anterior inferior cerebellar artery. So I'll draw that in this darker purple here. And again, that's coming off the basilar artery. You can just see how important this basilar artery is. And last, we have our posterior inferior cerebellar. And that one comes off the vertebral artery and serves the bottom bit of the cerebellum. A little bit tough to see on the anterior view, so I won't draw it in there. So those are the three major arteries of the cerebellum. See, when you group them like this, I find it's a lot easier to sort of digest it all. Alright, and finally we have the brain stem. So let's use green for our theme, our color scheme for the brain stem arteries. So for the brain stem, we have these branches that come off the basilar artery called the pontine branches. As a spinal artery, even though it's called the spinal artery, it still supplies a bit of the brain stem. So all of these, everything I just showed you, these are the main blood vessels of the brain.
Okay, now I'm not sure, for me it was easier to get all of that up front and then break it down. Usually I break it down and then I give it to you all as a whole, so if you're feeling overwhelmed, don't worry about it. Hopefully, again, a lot of that was review. Okay, let's go through it piece by piece. First, the circle of Willis, as he mentioned, contains this set of vessels that form a circle, and the circle itself serves, as we've seen in other aspects of brain functioning, it serves to provide some redundancy in blood flow, so that if there is a blockage, there's still alternative ways to get blood to areas of the brain. Particularly redundancy in relation to the supply of the basilar and the internal carotid arteries. And that doesn't mean that if you get a blockage of your internal carotid that you won't have any damage. But this redundancy can minimize the damage, or it can potentially there would be no damage. More often than not, there's going to be some loss of blood flow, but it can be minimized by this level of redundancy due to the collateral circulation that's provided by this circle. That's the main thing you need to know there. We will be going through this or practicing this diagram in lab today, but this is the one that we're going to work off of for this class. So again, you saw this in the video. The way I'm going to chunk it out in lecture is to talk about branches of the internal carotid artery, which are going to be, again, the middle cerebral, the anterior cerebral, which we see here, the ophthalmic, which he didn't mention, but it is a branch of the internal carotid, also the anterior choroidal artery, which in some cases branches off the MCA, in others branches off the internal carotid directly. And only about 20% of brains have this perfect or textbook circulation, meaning that the anterior choroidal does not always come off of the MCA, and the posterior or dorsal cerebellar artery, which isn't on this picture but we'll talk about, sometimes comes off the vertebral artery and sometimes comes off the posterior inferior cerebellar artery. So you're going to learn it textbook, but you're going to find that in some of your clinical practice that there aren't perfect strokes or perfect blood supply to any area. That's why no two strokes are ever quite the same. So again, you're going to have branches off the internal carotid. We'll talk about branches off of the basilar artery, right, which are going to be your posterior cerebral, your superior cerebellar, your pontine branches, and your anterior inferior cerebellar. And then we'll talk about branches of the vertebral arteries, which again are the anterior spinal artery, the posterior inferior cerebellar artery, and we'll talk about what the dorsal spinal artery does as well. And again, that's not going to be on this diagram. So let's start with branches of the internal carotid. The first major branch, as you saw, is the anterior cerebral artery, which is going to supply the medial aspect of the brain. And again, you saw him color in, it covers a little bit on the lateral surface, more so on this mid-sagittal section of the brain. So it's going to cover sensory and motor regions. Why? Because it's going to be supplying parts of the precentral and the postcentral gyrus. Okay? It's important to think about your homunculus here and what parts of the body are going to be represented on the medial surface of the homunculus. What do you think? Legs, right. So when you look at it here, the ACA territory is really covering parts of the trunk and then the lower extremities. All right, so this is a coronal section, and it can be a coronal section of the precentral or the postcentral gyrus, motor or sensory, it doesn't matter. That medial surface is going to be covering mostly the lower extremities, and you can see it here in blue is the area that's covered by the ACA, the anterior cerebral artery. So it's going to come off the internal carotid and supply primarily the medial surface of the brain. Because it's supplying aspects of the frontal lobes and also the cingulate gyrus, which runs here above the corpus callosum, it's part of our limbic system. If you have damage to the ACA, you may also end up seeing behavioral, emotional, or intellectual deficits as well as motor deficits. So again, if you lose ACA blood supply and you have damage to this area, you're going to potentially lose motor function, voluntary movement from the lower extremity. Would it be contralateral or ipsilateral? Contralateral, right, because your corticospinal tracts cross. What about sensory loss to the lower extremities? Contralateral or ipsilateral? Contralateral or ipsilateral loss? It would be contralateral because your dorsal columns and your spinothalamic also cross as they come up. So the right cortex is getting information about sensation from the left side of the body. So if you have damage to the left ACA area, ACA territory, you're going to have contralateral sensory and motor loss. And again, you may also end up having behavioral or emotional or intellectual challenges as well. We'll go through it again in application lecture. The middle cerebral artery is another branch of the internal carotid. As they showed, it's going to kind of dip down through this lateral fissure and supply the lateral aspect of the cerebrum. So it's actually supplying aspects of all four lobes. For the frontal and the parietal lobe, most of its innervation is going to be frontal and parietal lobe, and it's going to supply those other aspects of the precentral and postcentral gyrus. So we look at the upper extremity and facial region of the sensory and motor cortex. It's also going to be supplying your language centers of the brain, so Broca's and Wernicke's area. Broca's would be, well, it's hard to see on this open brain, but probably in this region here. Wernicke's back here. So the MCA is providing innervation to parts of the brain that do both receptive and expressive language. It's going to be supplying aspects of the temporal lobe, and we've got our visual stream passing through here. So you may see some, not visual deficits per se, but deficits in object recognition, because that's that ventral stream. And it's supplying parts of the occipital lobe. Primarily, it's going to be providing innervation to aspects of the optic tract and optic radiations. So what kind of deficit would you see if you damage the left optic tract and left optic radiations? Right visual field loss, so right homonymous hemianopsia. Remember, the final's cumulative. Okay, it's gotta come together. Hopefully today it starts coming together. The MCA also has some deep branches that innervate parts of the basal ganglia and parts of the internal capsule. Specifically within the internal capsule, it's going to be providing innervation to the anterior limb and the genu. What runs in the genu? What motor tract? You guys are dead today. Corticobulbar tracts run the genu of the inferior, or the internal capsule. So MCA loss of the deep branches, specifically to the internal capsule, could result in loss of motor innervation to parts of the face. Contralateral. Okay, so again, MCA territory, if we're looking at the precentral or postcentral gyrus, it's covering most of our upper extremity and face. This is what it would look like on a coronal section. This is what it would look like on the lateral surface of the whole brain. And you may be wondering if it's supplying both language areas, why you don't always get Broca's and Wernicke's aphasia at the same time. It's because the MCA does have different divisions and they're not always both affected. So damage to language centers are usually in the left hemisphere. Right, it's not the case for everybody, but for most people, language centers are on the left. So left MCA, superior division damage, could result in Broca's aphasia. Left MCA, inferior division damage, could result in Wernicke's aphasia. Again, Broca's area being around this aspect of the frontal lobe, Wernicke's being back here, the temporal lobe. Okay? Alright, another branch of the interior carotid that I want you to be familiar with is the anterior choroidal. Again, in some cases it may come off the MCA. We're going to talk about it just as a branch of the internal carotid. It is going to be a primary supplier also of optic tracts and optic radiations, again with some supply from the MCA as well. So again, if you have damage to the left optic tract and left optic radiations, what kind of damage would you get? Functional loss, right? Visual field loss, right? Homonymous hemianopsia. The anterior choroidal is going to do the posterior limb of the internal capsule. What kinds of fibers run through the posterior limb of the internal capsule? A lot of sensory stuff, right? Stuff going from the thalamus to the cortex. Some of that's going through the anterior limb as well. What major motor pathway is going through the posterior limb? Sensory. Motor pathway. Corticospinal, yeah. So a big one. Big one, okay? Posterior limb. Anterior choroidal is also going to supply the hippocampus. We'll be talking more about the hippocampus tomorrow, but when I say hippocampus, you think memory, yeah, emotion and memory. Anterior choroidal, we'll look at a picture in a minute, supplies parts of the basal ganglia. Also some parts of the thalamus, although it doesn't usually get credit for supplying the thalamus a whole lot. So if we look at just the basal ganglia here, what structure is this? It's labeled, I guess. Caudate. This is head of the caudate, body, tail of the caudate. Here's putamen from the outside. Deep to that would be the globus pallidus structures, and then more medial would be the thalamus here. So if we look at just the caudate, we've got supply from the anterior cerebral artery, from the middle cerebral artery, and the anterior choroidal artery. If we look at the putamen, again, we have supply from the anterior cerebral and the middle cerebral. And coming in here with the globus pallidus is going to be mainly middle cerebral and anterior choroidal. Thalamus is going to be supplied by the posterior cerebral and mainly the middle cerebral. Like I said, a little contribution from the anterior choroidal. So all of these branches supply some aspects of the cerebrum, but they often have branches that kind of dive deep and supply diencephalic and basal ganglia structures as well. Okay, that's internal carotid. We'll talk about branches of the basilar artery. So again, you saw in the video that the vertebral arteries are going to come together to form the basilar artery, which is here in the center. And then our branches, first branch is going to be the posterior cerebral artery, followed by the superior cerebellar artery, the pontine branches here, and then the anterior inferior cerebellar artery, which is sometimes abbreviated the AICA. I should say with abbreviations, you can abbreviate the cerebral arteries. Anterior cerebral artery is ACA, middle cerebral artery as MCA, and posterior cerebral artery as PCA. But it does get confusing. You can't write ACA and expect me to think anterior choroidal artery or anterior communicating artery. There's a lot of arteries that could be abbreviated ACA. So if you write ACA, the only acceptable answer for me would be anterior cerebral artery. Does that make sense? Okay. All right. The plastic brains that we have to look at in lab today also has the labyrinthine artery branching directly off the basilar. That only is the case in about 15 to 20% of brains. Most of the time it branches off the AICA, and that's where I have it here as a branch of that. We're not going to talk about it, but it does supply supply, the vestibular labyrinth, and the cochlea. Okay, so posterior cerebral artery you saw in the video in this diagram, it is represented in blue. So importantly, it is going to be supplying almost all of the visual cortex. So this back part of the occipital lobe. And so if you lose innervation to the primary visual cortex of the right hemisphere, what type of visual loss would you see? Left what? It would be loss of the left visual. It's the same thing as optic tract and optic radiation. You're going to lose homonymous hemianopsia. So left visual field loss in both eyes. Right. So posterior cerebral artery. It's also supplying the splenium of the corpus callosum. And remember when we talked about corpus colostomies, that they often try and spare this part of the corpus callosum. It's important in connecting the two sides, primarily of the visual cortex, but also of the part of the parietal lobe, somatosensory information, so that there is visual and somatosensory information going from the left to the right hemisphere and vice versa. So it's important to keep in mind that there could be visual deficits or visual problems associated just with even the loss of communication between the two hemispheres. The posterior cerebral artery does a lot for the cerebral cortex. It also supplies a good chunk of the midbrain. So in the midbrain regions, if you're looking at your slides, we're talking about like superior, inferior colliculus level. It's going to be supplying the cerebral peduncles. What types of information travel through the cerebral peduncles? What fibers? Motor pathways. Corticospinal, corticobulbar, corticopontine, so the ones going down to the pontine nuclei will eventually make it to the cerebellum, are all traveling in the cerebral peduncle. It's also supplying oculomotor nuclei, specifically cranial nerve 3 motor nuclei, and parts of the superior cerebellar peduncle. Again, if you can picture your midbrain slides, all of those structures are in that midbrain area. So PCA, and I'll show a slide showing the distribution, but it's supplying a good chunk of the midbrain. And again, we saw on the previous slide that it's going to be supplying a good part of the thalamus. It is also going to supply the subthalamic nucleus. And we talked about subthalamic nucleus strokes. What is the primary deficit that you're going to see if you have a stroke isolated in the subthalamic nucleus? Starts with an H. Hemiballism, right? Huh. Okay. Another branch of the basilar is the superior cerebellar artery. Again, these all work in threes, most of them. So you have 3 main cerebral arteries, 3 main cerebellar arteries. So the superior cerebellar artery luckily supplies the superior surface of the cerebellum. So in this diagram, it is in green. So this would be sort of a posterior, superior sort of view based on the angle. This would be the anterior surface. The surface would be facing the brainstem. So we have the superior cerebellar artery territory in green. It's going to supply the superior cerebellar peduncles, particularly in the aspect of the midbrain. So in this diagram, superior cerebellar peduncles kind of look yellow here. For the most, they've got a little bit of green. For the most part, they're going to be supplied by the superior cerebellar artery. So again, this matches superior cerebellar artery, superior cerebellar peduncle. Within the midbrain, the lower part of the midbrain and the rostral part of the pons, it's going to be supplying the medial lemniscal and the spinothalamic tract. All right, so our major sensory tracts coming in and up through the midbrain. So if you have loss of superior cerebellar artery, you're going to get loss of cerebellar function, but you could also see sensory deficits as well if the loss is affecting the midbrain supply cerebellar peduncles, which are decussating, are also being supplied by the superior cerebellar artery. Most of the rest of this that is sort of in this pinkish color and the dark purple is all posterior cerebral artery. So branches of the posterior cerebral are in dark purple, primary posterior cerebral is in the light pink. So again, oculomotor nuclei being supplied by the posterior cerebral, a good chunk of our cerebral peduncles also being supplied by the posterior cerebral artery, and those corticospinal and corticobulbar tracts are traveling in this main, well that's these here, in this main bulk of supply from the posterior cerebral artery. Again, we're still talking about branches of the basilar artery. We have contributions, or a branch from the inferior cerebellar artery, which in this diagram is yellow. So if we look at the anterior surface of the cerebellum, a good portion of that is being supplied by the AICA. Again, this diagram is yellow. You don't see as much. It's got some lateral contributions to the lateral hemispheres on this view, but primarily supplying the anterior surface of the cerebellum. It's also going to be the major supplier of the middle cerebral peduncle here. And within the pons, it's going to supply a lot of the brainstem nuclei in the pons. And the ones that I want you to be aware of are the trigeminal nuclei. So trigeminal is coming sensory from the face. The vestibular nuclei and the abducens nuclei. Abducens nuclei does what? General. Eye movements, right. So, if you're getting a clinical case and you're seeing cerebellar dysfunction, you may also see problems with vestibular functioning. You may also see loss of sensation to the face. That's going to tell you that the supply is probably, or the loss is probably coming from a loss of blood supply from the anterior inferior cerebellar artery because of its contributions to this area of the pons. The pontine arteries he showed you, I'm going to stop picking that up because I just keep dropping it. The pontine arteries are going to supply, they're going to be these smaller branches that come right off the basilar artery. There's multiple branches. They're supplying the pontine nuclei. Pontine nuclei are receiving fibers from where? From the cerebral cortex. Remember, corticopontine tract, right? And then those fibers are going to go where? From the pontine nuclei to the cerebellum, right? Mostly through the MCP to the cerebellum. So yeah, I have this here, corticopontine fibers, corticospinal, corticobulbar tracts, and again, those from the pontine nuclei, you would have fibers going to the cerebellum. It's also going to supply portions of the medial lemniscus in the rostral and caudal pons. So in addition to the superior cerebellar peduncle. Yeah.
Can I go back to the last slide and ask a quick question? So the inferior cerebellar artery, if it's affecting the middle cerebellar peduncle, that's that like motor information or the information from the cortex that goes in, and then you said that like a lot of times it was like the gait and the falling to the side, and then with the vestibular deficits, how do you tease that out? Are they going to look similar, and how do you tease it if it's one, if it's the other, or if it's both? Does that make sense?
Well, if you have global cerebellar deficits, you're not just going to see the staggering gait. You're going to see other symptoms like dysmetria and dyssynergia and all of that as well. With vestibular, you're going to see not only sort of the instability with gait, but you may also see nystagmus. You may also have things like nausea and potentially vomiting going along with it. So those could also be signs of vestibular dysfunction. In this case, you're probably going to see a mixture of all of that because it's supplying both of these regions. Yeah, Anthony.
For this nystagmus real quick,
nystagmus, but you're probably going to be asking them to move their eyes. It's not necessarily a resting nystagmus. Any other questions? Okay. Pontine arteries, did that. All right, so last set are branches off the vertebral artery. A and N and sun. So the vertebral artery is going to give off the posterior inferior cerebellar artery, so the third of our cerebellar arteries, which is here, way down at the bottom. Also the anterior spinal artery, which is here, and it's going to run along the ventral surface of the spinal cord. And then again, this is one of those anomalies that the dorsal spinal artery or posterior spinal artery sometimes comes off the vertebral artery directly. Other times, more often, I think 75% of the time, it comes off the posterior inferior cerebellar artery. So it would be a branch off of this. So you need to know the dorsal spinal artery. You don't need to be able to label it on this diagram. So posterior inferior cerebellar artery, sometimes abbreviated PICA. Don't call it pica, that means something else. But the PICA supplies the posterior surface of the cerebellum. So in this diagram, it is in red here. So it's covering aspects of the vermis and aspects of the lateral hemisphere, and a little bit on the anterior surface of the cerebellum as well. Notice it's supplying the nodulus. It's also going to supply the inferior cerebellar peduncle, and I've simplified the peduncles a little bit so that you kind of superior matches superior, anterior inferior matches middle, posterior inferior matches inferior. It's maybe not as clean as that, but we're going to use that breakdown for this class. It's a little easier to remember. The other thing with the PICA is that it's going to be supplying aspects of the medulla. And so specifically the area that it's going to cover is the areas of the brain, the lateral aspects where the spinothalamic tract is running. So remember, spinothalamic is running very lateral at the level of the medulla. It is already crossed because it crosses at the level of the spinal cord as soon as it enters. Those spinocerebellar, the dorsal and ventral tracts that you saw last week or 2 weeks ago in lab that run right along the edge of the spinal cord continue to run very lateral at the level of the medulla. And it's also going to innervate the nucleus ambiguous, which we have not talked about. I haven't required you to find that in lab. But it is the motor nucleus of cranial nerves 9 and 10, which are going to innervate, and primarily what we see with these two, are innervating muscles in the pharynx and the larynx that are used for swallowing and phonation, for voice quality. So what you may see with damage or loss of supply to the nucleus ambiguous are difficulty swallowing or dysphagia, or issues with voice resonance or phonation. So the quality, voice quality versus the actual inability to speak. Last two for today. The dorsal spinal artery, I'm going to do this one first. I think this is pretty easy to remember. Its major supplies to the dorsal column. So in this picture, it is what's represented in green. It's going to supply the fasciculus gracilis and cuneatus in terms of within the spinal cord. And then at the level of the medulla, it's also going to innervate the gracile and cuneate nuclei. So it's going to take care, it's going to supply all of those sensory tracts, the DCML tracts that are coming in to the spinal cord, running in the dorsal aspect of the spinal cord and synapsing within the medulla. It's also going to supply portions of the inferior cerebellar peduncle. So again, with the PICA innervating the inferior cerebellar peduncle. And then the anterior spinal artery, is going to supply everything else. So all of this region here that is shaded in or graphed in. So it's going to run along the ventral aspect of the spinal cord, innervate all of this territory down here. And most of our motor tracts are running here. So our lateral corticospinal tract, our anterior corticospinal tract, our vestibulocerebellar, our vestibulospinal, reticulospinal, all of those motor tracts are running within the territory of the anterior spinal artery. At the level of the medulla, it's also providing innervation to the pyramids, which would, I don't have a picture of the medulla, but would be along this ventral surface of the medulla, areas of the medial lemniscus, the medial longitudinal fasciculus, the inferior alveolar nucleus, and the hypoglossal nucleus. So a lot of innervation to the medulla as well as the entire ventral part of the spinal cord. And so this is just another picture showing supply of the posterior dorsal spinal artery in blue, your dorsal columns, and then your ventral or anterior spinal artery in the light pink. Again, just showing the lateral corticospinal tract and the spinothalamic tract, but we know that a lot of other motor tracts run in this area as well. And then finally, the brain is drained, or the supply is drained by this system of veins that empty into the dural sinuses, and the sinuses empty into the left and right jugular veins. And I'm not so concerned, you don't need to learn the venous drainage system, mainly because problems with drainage aren't frequent, and it's often not something that is going to, because they're not frequent, we don't often see them, it often isn't going to lead to a functional loss. The one thing you do need to know is that if there is too much pressure in the venous drainage or in the sinuses, what you're going to see is hydrocephalus. So you're going to see a swelling of the brain. And I think in the first lecture or so, we talked about how if there's too much buildup within the dural sinuses, that's one way we can have hydrocephalus. If there's buildup in the superior sagittal sinuses as well. Also, if there's too much pressure on the ventricles, would be another way that you would see hydrocephalus. So swelling of the brain and a lack of drainage through the cerebral, within the cerebral spinal fluid. So, huh?
What was that word again?
Hydrocephalus. And symptoms of hydrocephalus, often that buildup of pressure, you're going to see it in terms of a headache. People complaining of a headache going along with potentially other symptoms as well. So my tips for you today are to try and visualize as you're going through, particularly on the brain models, what territory the arteries are supplying, and then to kind of think about, okay, well, if we lose this part of the precentral gyrus, what's the deficit going to look like? If we lose optic tract or optic radiations here, what is that going to look like in terms of a deficit? So really trying to link artery to what is it supplying to what would this look like if we lost it? And again, hypothesizing what functional loss you would expect to see. And what we'll do in the afternoon is I'll break it down again and say, okay, ACA damage, what would this look like? MCA damage, what would it look like? And then if we have time, I have 3 clinical cases for you guys to practice. If not, you need to do them on your own, because that's the level I want you to get at. Is if a patient presents with this, where is the lesion? Like, that's where we need to get to. And you need to be able to work both directions. So a patient presents with this, here's the lesion, or I say, here's the lesion, here's the damage, what symptoms do you expect to see? All right, so you need to be able to work both directions. So you really need to start thinking about blood supply, territory it's supplying, what is the function of that territory, what would the loss look like? So quiz yourself as you go. There's a certain amount of memorizing, but then there's a certain amount of, you need to take it to the next level. Like we're in the last 3 weeks of class, and you've got to start putting it all together, okay? So you have your lab guide. I'm not doing a lab intro because a lot of it is based on what we've done today. I can get the wet brains out. There is not really, like, most of the blood supply is gone and what's there is not easy to distinguish, so, I probably will only, are you guys laughing because you were such good dissectors? So I will probably only quiz you off of diagrams and the plastic models. Oh, sorry, I'll clean that up. It's been a rough day already. I don't have a copy of the lab guide. I'm gonna steal yours. So I want you to work off this picture to start, but there's only 2 plastic models that have blood supply on them. So what I would encourage some groups to do is to steal those first. And go to number 3 on your thing and start going through where they are on the plastic models, because everybody's going to have to share those today. So there's a tendency to just want to do number 1 because it's easy and you just have to label it, but then everybody's going to get to number 3 at the same time and want those frames. So somebody take initiative, start with the brain, and then pass it on to another group. Okay? All right. So I'll see you guys downstairs in 20 minutes.